Okay, we've got this part of the pulley machined, so that surface there is true to those two surfaces there and to that edge of the pulley. The problem I face now is that I now want to turn the pulley over and put it in the chuck that way to machine the back surface. And of course, if the chuck is not dead true, then the back surface won't be parallel to this surface. So, and that's important, otherwise we'll end up with a run out between the two pulleys. So what I'm going to do now is just put a dial gauge on these faces of the chuck, which are the faces that I'll be using. When I put that into the chuck, it'll be against those faces. So we'll dial up the chuck and just see how good the chuck is. Okay, so we're just checking the the jaws of the chuck here. And as you can see, the jaws are pretty good. So we're pretty confident that if we set the disc back against those flats on those jaws, then the disc will be running true, because the previous surface that we machined was that one there. So, and which is true to the board hole. So if we set it against the jaws on those faces, after cleaning the jaws, then I'm fairly confident that there will be no error on the rear face of the disc. Okay, so we've finished half of the product, and I'm just going to mentally run through which surfaces are true and which may not be, and what we're going to do next. So we've had it chucked in the jaw in that direction, and we've turned that face there true, and we've turned that face, those two faces in there true, and we've bored that 25mm hole. So those faces are all true to each other, and likewise this half of the periphery. So from there out, across there, down there and there, those faces are all true to each other. So what I want to do now is turn it around, put it in the chuck, and turn a spigot around here. Now unfortunately, if there's any error in the jaws, then that spigot won't be quite true to that to this bored hole, and that's the only reference that I can measure when I get it in the chuck. So let's put it in the chuck and measure it and have a look at it. So what I want to do is turn a spigot here, but it has to be concentric with that bored hole, and we know that that bored hole is true to the face on the other side. So we'll put the gauge in here, and I'm not sure whether you can see that or not. Hopefully you can. Now this is a 100th millimeter dial gauge, so we've got about 6/100ths there, which is about 2 thou. So we're 2 thou low, on this jaw here, which is here. Now I don't know whether that 2 thou low is because of the material or because of the jaw. So what I'm going to do is turn the billet around 180 degrees and rechuck it. and try again. And so if the low spot moves to this side, then I know the product, the billet has the error. If the low side stays here, then I know the jaw is low. And if that is the case, then I'll be able to fix it by packing the jaw out. There's the low spot, and the low spot corresponds to the same jaw, which is good news. And I knew this before anyway. Now so I know that this jaw is about 2 thou low. Now I've got a 3 thou piece of shim here. It might be too much, but we'll try that. So if I shim this jaw out, with the shim, make sure there's no swarf on there. Right, so the low spot is opposite the shim now, so that tells me that the shim was too thick, and the low spot is about the same error as it was before, so I need a shim half that thickness. Right, so I now have a piece of 2 thou shim, so I'll put the 2 thou shim in there and chuck the billet in the same place. Right, so we've got about half the error, and the low spot is there. So that shim is still too thick. That's 2 thou, so we need a 1 thou shim. Right, so I don't have any 1 thou brass shim unfortunately, but I do have some 1 thou foil. Yeah, we'll try that. The low spot is there. Right, so it's still low, so it's low by about 0.05 millimeters, which is about 1.5 thou, so I need to double the foil thickness because the low spot was in the same place. Unfortunately it's aluminium foil, which is probably a bit soft. Alright, so we've got about 3/100ths there. I could probably get it better than that. with our low jaw. I'm putting the billet in the same way around every time, so we don't introduce another error. Right, that's pretty good. We've got an error there of about 2/100ths of a millimetre, and 100th of a millimetre is 0.4 thou, so 0.8 of a thou. I could probably get it a little better if I played around with the more shims, but the job probably doesn't warrant that. And just as a quick check, we'll check this face now. This face doesn't actually matter, but it'd be interesting to see how good this face is. Zero. This is a 1 thou gauge, so I'm pretty happy with that. And it shows you what you can do with a Chinese 3-jaw chuck. Nothing special about this chuck. I've had it for 20 odd years. I have looked after it. You'll notice that, I don't know whether you can see the back plate, but the back plate is bolted to the chuck, and by loosening the bolts you can actually move the chuck on the bolts. I didn't do that some years ago to get the best run out I could. So what we're going to do now is turn a spigot here to fit the inside of this pulley, and that spigot diameter is 39.97, and I'll just work out the depth in a minute. I haven't got that at my fingertips, but we'll stop the camera, I'll work that out, and then we'll get started. Okay, so I need a 2mm high spigot here, so I need to take 2 mils off this39.97, and the spigot is in diameter is exactly 39.97. So I'll write that here, 39.97. Selecting the right tool here. Just got to turn that tool around in the tool post because I've got it facing the wrong way. They call that Hook's law, I think. Right, so I think we are just about on the money here. Unfortunately I have to measure it with calipers because I can't get in here with a micrometer, and I can't actually try the pulley in here because the pulley won't get past these jaws. So I've measured the pulley as accurately as I can with an internal gauge and using the calipers, and I reckon we are 0.1 millimeters too big. So I'll just take a spring cover off there. Right, 39.96. And I make the pulley 39.93. So 0.03, which is 3/4 12, 1 thou. So I will rather have it 1 thou too big than too small, I think. So what I'll do now is go to the depth of the back of the face, lock the carriage, and then come out. I've got a flat face. Right, didn't do that right. Take the shoulders off. It's a problem with cast iron, you get cast iron dust everywhere. We cleaned the lathe about 3 times between filming. People are going to tell me that my chamfering tool is at the wrong angle, and I agree. Right, so we've got no option now but to take it out of the vise, out of the chuck. So what I will do is mark the face with this low jaw, so that if I do have to put it back, then at least I've got a fighting chance. And we'll keep our shim. We'll keep our shim at the bottom. Too late, we've lost it. Now with a bit of luck, this should fit in the pulley. Well, would you know, it's that 1 thou is enough to stop it going in. So we're going to have to put it back, dial it up, and try and take a thou off there. Right, okay, well we've just put our billet back in again. I've got my shim in there, and I'm actually registering on the edge that we've just turned, and even I can't believe that it's as good as it is. That's about 4/100ths, and less than that, 3/100ths, which is about as good as we're going to get it, I think. So the object of the exercise now is to try and take a smidgen off the collar, and I think what I'll do is I'll go and put a magnifying glass on. Okay, so I have one of these which lets me see a bit better. So we'll put some light on the matter. Right, so we're touching there. Go in 0.02. Right, got no option unfortunately but to take it out again. Give it a wipe. And it fits. It's a tight fit, which is good. It's a snug fit. So I can get it in with the lead block and it doesn't fall out. And the pulley registers on the other side, and we've got about a 2mm space. So yes, I'm quite happy with that. There's no rock, so what I've got to do now is mount this up in the dividing head and the rotary table, and bore the 4 clearance holes for the hold down bolts. Good thing I'm not doing this for a living.